Hello, this is Dr. Y.S. Rao, Director Go Green Technologies Private Limited, Vice Principal, Dean Academics and Research from Sardar Patel Institute of Technology, and also heading the SPIT ASCT Idea Lab. So this session is about to understand what is project, what is product, and what is research. And while doing this, what are the expected outcomes in terms of publications, patents, or some funded proposals? These are some of my affiliations. All right. So we understand that during our engineering, we are supposed to do some mini projects, major projects. Some of them are 2 months, some of them are 6 months. We also do some internship programs where uh, we do have some credits for that. Some of them are 12 credits, even 15 credits. Sometimes we do it within the institute, sometimes we do collaboratively with some research laboratories. There are some expected outcomes during our mini projects and major projects or research internship programs. So these are all called academic because some credits are assigned. So we are supposed to do some uh, work as a part of our academics. There may be a mentor, internal mentor, external mentor. There may be time to time evaluation. In the latest academic policy, national education policy, it is mandatory to do not only mini and major projects, even some of the laboratory courses also could be fully project oriented. So no need of doing the practicals. One full course you can do project. Otherwise, government has insisted that there should be some internship program, minimum 6 months in your final semester. Hope you can understand the amount of weightage given to a project. So what is project? A project is majorly looked as a learning. Some learning should happen other than what you do in the laboratories. Whatever you have not learned, that you are learned with the help of the project. Whatever is not covered in the syllabus, that you should learn during the project. Whatever is the laboratories you have done individually, can you do it in a group? Because it is also important your leadership qualities or working in a team. How do you distribute the work? Because these are all the industrial expectations. So this experiential learning has given major weightage in engineering academics. So you can understand that the whole world is whatever you see in your day-to-day life, these inventions, whatever you see, these are all the inventions done by the past generation engineers. That means one has to visualize what you are supposed to do, and eventually it becomes a reality. However, while doing the projects, what is expected is there any learning is happening or not? It might not be a product which you have developed, but at least if I am given 2 months, the 2 months, right? Hope you can understand, daily 8 hours, weekly 40 hours, similarly monthly multiplied by 4. So those many working hours because there are credits assigned to that. So based on the number of credits, those many hours of work have you done or not. So it's about the learning. So what do you learn while doing the projects? Probably what you do is you try to find out some industrial websites, right? The people who are manufacturing some electronic products or software products, or whatever, whichever is the field you belongs to. From those websites, you try to read the application notes, whatever is the right problems they have solved. So it's not that you have to create a new product or right you have to solve some problems. Whatever they are there, their application notes, as it is also if you implement, a maximum learning happens. We called as a re-engineering. Or academics point of view, if you see, you have some international publishers like IEEE, IEEE, ACM, Springer, Elsevier, Web of Science, Taylor and Series. So if you look at their websites, the publishers' websites, or if you subscribe through your library, you may find some published work. So either the company's application notes or the publisher means some universities have published their work. We generally go through those published articles, papers, conferences, journals. As it is also, if you implement, that itself is a learning, maximum learning happens. So either by keeping in technology, whatever the latest technologies which are learned in your academics, or the published work, because published work means it's a, you know, at least one full year, some scholars have done some work and they have published. So that if you are able to implement it in 6 months of time, that itself is a learning. Some learning happens. So that is called, generally we call as a projects. However, unfortunately, what is happening, project means nowadays, last 10-15 years, students search for the projects online, some popular portals, or some companies have started where they are supplying this brochure material or the ready-made solutions. So or now we have the chat GPT and all those tools. So if you are looking those blogs, popular websites for projects, then the question arises here is there any learning happening or not? Because what is the purpose of a project? Those many hours, 2 months, 6 months, those many hours of hard work you have to put joyfully. No copy paste sort of a thing. It is you have studied, you have learned, and you have implemented. So if that kind of thing is happening, then we can say you have done a project. But if project is already available online where the circuit diagram or the programs, reports, if everything is available and that is if you propose in your academics, then you are not doing a project. What you are doing is copying the things from the public domain or some commercial people and you have submitted, which is a crime. So you have committed a crime by copy paste the things. So this actually in UGC also it is clearly specified. Even in the international any universities, if you see the ethics, that clearly stated that at any point of time, not only during graduation after graduation also, if the work is as it is copied from some of the websites, somebody's work, then your degree may be cancelled because you have done copy paste. That's the reason why, to validate the academic projects, why we ask for publication. The reason is the publisher takes a copyright from you, that you have not copied from anywhere. It is your genuine work that you are certifying. That's the reason why, as I mentioned, these 10, 15 popular world international level publishers, there is a clause where you have to agree, then only they publish. They also use some tools while doing this, that's called plagiarism check, that is similarity check software they use, like Turnitin and so on. So if they found, if any of your contents of your report or your articles or journals, papers, whatever you have written, if 10%, more than 10%, if they found a similarity, then they reject. That's the reason why the validation of the project, we always say publish a paper, a standard publishers, not the nowadays this on the name of international, some open source or these money making uh, publishers have come up. Not those publishers, the genuine publishers whose impact factor is very high, citation is very high, and they are indexed, Scopus or SCI index or Google index, right? Some of these agencies are recognizing the published journals, international recognition. So there is a, on a scale of 5 or a scale of 10, they rate these publishers and the papers or the authors. So we need to look at, right, the quality of your work, even if you are doing a project as an academic project. So we will discuss the how to do the project and how to write a standard paper. There is a I have recorded a separate session for that. What is a documentation? How to create a your research work, your published work, your work, your project work in a standard document form. I have separately recorded that. I will show you at the end of the session. Now let us discuss about what is a product. A product, first we need to understand, when you are developing a product, then it's not just for the publish of a journal publisher publishing the paper. The purpose of doing a developing a product not meant for publishing in a conference or publishing uh, to the by the publisher. First of all, you are not supposed to publish. You are not supposed to disclose the work you have done in the public domain unless it is patented. So that means there is some another agency who verify your work, and also they also see the similarity checking, and they sanction the copyrights authority on your work, so that nobody can copy your work at least another 20 years. After 20 years, right, the whatever is the claims you have made, other peoples can repeat that work. So that is the kind of protection you get instead of publishing a paper if you patent a paper. So there are series of steps which we will discuss separately about the intellectual property rights, IPRs. So the outcome of a product development is patented work. So that is expected whether you develop the product in 2 months or 6 months or 1 year, don't publish in a public domain, publish in a patent office. It's a, for example, in India, we have a government of India patent office is there at different regions. Similarly, international journal wise, they have patented territories. This is one aspect of product and patent. Outcome of the product is patent. But however, the other aspect of a product is commercialization. Can we sell our the kind of work which you have done in 2 months or 6 months or 1 year? Can we sell it in the market, national or international market? Does anybody is interested in investing in the kind of work you are doing? That means it's a business. So if you are working 2 or 3 people, 2 months to 6 months, why can't we convert our work into product form where there's a possibility of getting a job or getting a investment? Other than India, if you see most of the US, right, Germany, Japan, European universities, the research is actually sponsored. Nobody pay the fees for doing the research. In fact, researchers are paid because it is a funded research by the industry. So once the industry is funding, then you are not supposed to disclose the work which you have done in the public domain because it is a confidentiality is involved. Then the work you have done, they are expecting some business, some revenue to be generated. So probably they may patent it first so that nobody can copy it, and eventually they convert into a product form. So while doing the academic work, we recommend that don't go for projects and publications. UGC, Government India, even several IITs, autonomous institutes, are now saying that go for product development. Even if 1% of any projects, if they can convert into products, then first you will benefit. There will be, you get investment, society will benefit, industry will benefit, country will benefit through IPRs and the revenue generation. So that is the reason when I am saying a project, it's not about searching the projects on the public domain. Do the literature survey, refer the various companies' websites, refer the standard journals, see is there any possibility, is there anything which you are solving for the industry, any issue are you solving so that there is a possibility of investments. So think of the products, not the projects. Even UGC also clearly says that don't do publications, do patents. Even the Department of Science and Technology, AICT, UGC is providing a fund through Institute Innovation Cell to fund your patents. So they are paying the fees. You don't need to pay the fees. Even the patented fees, the government is paying. So let's think of in terms of innovations, not only just a learning, but there is a possibility of commercialization, a slight incremental improvement in the existing products. You don't need to invent a new product. In the existing product also, a slight improvement may make it commercialization. So that we will see again, discuss separately what are the products which can be patentable and who are the agencies are investing ready to fund for your products, product ideas. I hope now it is understood the difference between a project and a product. The third aspect is about the research. What is research? Research is there is some thin line, thin gap between engineering and research. Most of the times we think that extension of our projects is research, right? I have done some work and some more work if I do it, that's the research. That's the general perception students are having. In IITs and some autonomous institute, if you continue your work after BTech, go for MTech, or without MTech also directly you can jump into PhD. Not necessary you should acquire a PhD, otherwise also you can do research. Some of the research laboratories like BRC, TIFR, you don't need to have a degree, otherwise also you can be a research scholar. So what is research? First, research is not about implementation. Research is not that day one you are talking about the development. Research is not about the immediate experimentation. First, research is about some philosophy, right? There is some problem, there are some issues. First, develop a hypothesis, right? Hypothetical statements stating that if 1, 2, 3, if I am able to do these things, then over a period of time, 2 years or 3 years, what could be the possible outcomes which where it may add some value addition to the existing knowledge. Today's knowledge, right, if it is X, then after doing your research, you may add in delta T to X, X plus delta T. That means today you are sitting on the shoulders of the knowledge, and from there you are adding delta T to the existing knowledge. That is research. So it's a philosophy. That's why they award as a doctor of philosophy, PhD, irrespective of whether you are a science, arts, commerce, engineering. They give PhD, doctor of philosophy. Means you are a philosopher. While doing the research, there may be types of research. Some researchers are fundamental research, some researchers are applied research. Fundamental research, when you are doing, then probably you may require the kind of background, you may require that kind of environment is altogether different. Like I said, BRC, TIFR, or few IITs are having that kind of a doing the research in the basics of science. In the basics of science itself, you are doing research. That is a conceptual research. However, that kind of facilities are very rare. So what we do, we go for applied research. Applied research means we look at the various domains and we try to apply our knowledge in those domains. So it is generally multidisciplinary in nature. You acquired some knowledge in a specific domain. However, with this knowledge, you are solving some issues, the problems in some other domain. So it's like that's why we call it as applied applications of science. Or more or less, engineering is all about applications of science, applied science. However, while doing research, as I said, immediately we don't jump into experimentation, development. We start with first the hypothesis, define the objectives, then we do first the literature survey. After that, first mathematically model the problems, not the experimentation, not the products. First, prove on paper that there are some issues exist, and those issues you are able to, with the help of, by contributing your knowledge, you are able to solve them. So first the mathematical model comes into picture in research. After that, probably today you have a lot of computational systems are available. Those mathematical expressions, convert them into program form and simulate it. Most of the people end up their research by simulating those problems and giving some solutions. Some of the people also experiment it, prove that by building the such kind of applications, which is slightly complicated in nature, because you are doing first time, which doesn't exist. As I said, in the existing knowledge, you are adding a delta t to that. In the entire world, some work is already done. You are adding a delta t to that knowledge. That's the research. So what is the outcome of the research? Highest degree, right? You have acquired a PhD degree because you have contributed. That means anywhere in the world, once you are awarded as a doctor of philosophy, that means you are the highest degree holder in that particular domain. You are a philosopher. You have your own domain. You have established some domain where you will be contributing through that knowledge, either academically or industrially. Wherever if a problem exists, then people are approaching you because you are an expert in that particular domain, because you have achieved the highest degree in the university system. That's the, outcome of your research. In the society, you are recognized as a highest authority in that particular domain. Lifelong, you have established your own domain. All right. So otherwise, while doing research also, you can do world's best publications, what we call as a transactions, right? Or journals, the best journals. Hardly we have two or three best journals. So you can publish there, or you can also do patenting, because research is also funded. So they do not want to publish your work. They wish that kind of a research should be patented so that nobody can copy it. I hope now it is clear to you that what is project, what is product, and what is research. There is a thin marginal difference is there between academic learning, industrial projects, and a research where you are adding a knowledge. The outcomes also I spelled out. Are you looking for some jobs because you have learned with the help of the project? Since you have acquired some skills exponentially, which has some significance in terms of tools and technology, so you will get some internships or you get some jobs through project. If you do a product, then some industries not only will invite you to start a company, but there are some investors. While converting your idea into prototyping, you may get some investments. You can start your own company. However, research is the highest honored degree. That's the outcome. And then you become an expert at national or international level, so that the agencies will approach you in your domain as and when they require help or opinion. Those are the outcomes. All right, so like I said, the expected outcome could be in terms of publication or some copyrights or some IPRs. There is a possibility of getting internship or some employment. You can also start your own company. There is a government of India support is there for students and faculty. They provide money grant for converting ideas into product into business. They also providing seed money. There are investors, angel investors, venture capitalists. They also come to the campus wherever the technology business incubation centers are there. These are all some possible outcomes for projects, products, and research. We need to understand one thing: there is a timeline for every work. If we don't finish in time, there is a possibility that your work is obsolete. Either publisher won't accept your work or patent office won't accept your work. Industry says that it's already exist. There is no possibility of revenue generation. Or even if you start a company, if you are unable to commercialize it in time, then again you have to start developing the product. Or even if you're a successful businessman, but don't think that lifelong you can sell your product. There is a growth, there is a maturity, and there is a decline for every product. So profits will fall down once again. You have to reinvent, redesign your product again and again. That's the cycle of any project or product or research. What are the characteristics of a successful project or product or research development? You need to look at, first of all, the quality, how good it is. Like I said, maybe either compare in terms of some published work or industry validation, how good it is. Then, since it's about there is a also development is involved, find out the cost. Is it feasible or not, right? What is the total cost of your product development? Then how much time you take for converting your idea into product? It's important. And the development cost. Research cost is different, development cost is different. Research cost is all about the ideation, proving, right, the principle, right? We say proof of concept. However, development means now you have proved the concept, now it goes for the manufacturing. So that's a production. Development capabilities. Whatever is the problem you have taken, the solution, if you want to implement, do you have the capabilities to build that, develop that product? Let's say, for example, you want to solder a multi-layer PCB where the components are tiny in nature. Do you have the ability to fabricate such kind of the PCBs? Or let's say you require some platform where you need to compute terabytes of data. Do you have that kind of a computational facility to implement your problem statement? So you have to look at the capabilities while doing that particular work. So these are some successful characteristics you have to look at while choosing the problem statement: the quality, the cost, the time, the capabilities. While doing this, so specifically in this session, we are talking about electronic product development, which consists of some software. That means it is actually a software, but not 100% software. 100% software means you are doing everything on a personal computer. Then we say 100% software. The reason is you are not developing the computer. You are only using the computer and writing the program. Though it's not a 100% software, there is a hardware is there, like computer, CPU, i3, i5, i7, i9, some resources. There is a hardware definitely, but since you are not touching, you are not studying, you are making assumptions about that particular computer product, we say you are interested in a pure software development product. Generally, that kind of a product development, 100% software product development, getting a patent is also very difficult. It's very, very difficult for a software patent, making a product out of it. That is one reason. Second reason is, if it is a 100% software by using a computer, when you are making all the assumptions about the hardware, then it's only a question of the programming languages and the mathematics, logical thinking. That kind of work can be done by diploma, degree, art, science, commerce, science graduates, or the multidisciplinary area degree holders like MBA Tech, MCA, and so on. So these are the streams where there is no engineering is involved. They're only a graduates of different disciplines. They make assumptions about the computer hardware and they only write the solutions by using some programming tools. So that is the kind of competition involved where most of this kind of a work you will find even engineering also people having degrees from civil, mechanical, electrical, instrumentation, production, chemical, metallurgy, textile are able to develop, give the solutions for the 100% software products because you don't need to understand the hardware or the architecture. There we make the assumptions. No need of technical background, technology background, no engineering knowledge is required. So it is mass. That is the, I would say, 100% software projects. Patenting is also very difficult to get for a software. Publishing a journal papers, unless you have a strong mathematical background, is difficult. Let us look at the other way around. The software is there not only in computer, in millions of applications, millions that we will see. What are those millions of applications? But the hardware is not computer. Hardware is not from IBM or Intel i3, i5, i7. It could be some other architecture. It could be some other organization. It could be some other CPUs. The computational units are there in thousands of computational units are there where software is there. So that is the reason we always advocate all the engineering graduates, particularly including students who are interested in developing the products. We always say that look at the market size, look at the kind of investments are happening in the manufacturing sector where there is a software is there, but however the hardware is application specific systems. What is a application specific system other than the computer? Very simple definition. Wherever you see a software other than the computer, that is called a application specific system. So today, whatever we are doing in this coding, in this training, in this hobby club is about application specific system where the hardware, the architecture, the organization is specially designed for a specific application. Whatever you see in your surroundings, starting with mobile phone to air conditioners, refrigerators, microwave ovens, smart watches, electrical vehicles, gadgets, nuclear power reactors, bullet trains, spacecrafts, drones, driverless cars, missile guided systems, consumer products, healthcare products, agricultural products. You name a product. Today, there is a software is there. Huge business is happening. trillion-dollar industry it is. However, it's not about the computer, it's about computerization of the objects. That's the demand. So in short, you need to understand what is application specific system, software and hardware development. Rather, it is a partition. You have to partition the software and hardware in such a way that as per the application, you need to decide how much amount of hardware is required, how much amount of software is required for a given application. So when we start this kind of a product development, we start with minimum system, not the maximum system. We don't populate everything. We start with basics, step by step. Reason is we are doing everything on our own. We are designing, developing, fabricating, testing, everything on our own. Naturally, one should not fabricate everything in one shot. Similarly, one should not write the entire code, entire project code in one shot. Both of them are disastrous. Bugs are bound to be there. Since we are doing first time, there is a possibility of mistakes. However, the mistakes in hardware are very, very expensive. You may permanently damage the components. Or the software also sometimes may lead to damage the hardware if you have not done the coding properly. So that is the difference between a developing a project by using a computer and developing a product application specific system. So what is minimum system? Minimum system means minimum components. If you look at this diagram, a minimum system, what you find is undoubtedly there is a CPU. This CPU will function only when A, if power supply is given, being a semiconductor device, electrons will flow only when you energize. Current will start flowing from positive to negative, that is flow of electrons, when you energize, when you give the power. So desired power you are supposed to give. What is desired power? Maybe it's working on 5 volts, 3.3 volts, 1.2 volts. It depends. Whatever is the desired power, you should give it. That is first step. You should do that to the CPU. Second step is, being a digital system, you are supposed to give a clock. The CPU, every instruction is fetch, decode, execution takes place based on the clock, operating clock. Without the clock, the CPU cannot function because it is a digital, it is synchronous. So clock is mandatory. So look at the data sheet, whatever is the operating clock that you have to give it to the CPU, then it will start functioning. The third is, every CPU has a reset, like you have seen in mobile phones, you have seen in your computers, you have seen your laptops or some other instruments also, there is a reset button. What does the reset do to a CPU? restart. Restart means, as we know, without a program, the CPU is a dead system. If you don't feed a instruction, it is like a body without a soul. You cannot see the soul. If the soul is inside the body, then we called as a human. If you remove the soul, then it's a body, it's a dead system. Similarly, inside the microprocessor CPU, if there is a program, then you can expect the behavior of the CPU. If there is no instruction, then it is a dead system. So if you press a reset button, the CPU will execute the first instruction. In your program, always the first instruction will be executed whenever you press a reset. Your program could be anywhere, but it will restart. So make sure in a minimum system, the CPU has power supply, CPU has clock, CPU has given a reset signal. Then it will start executing the program. Then probably connect some LED or something which will indicate the program is getting executed. As you can understand, this is not a computer. Naturally, it doesn't have any LCD monitor, ASCII keyboard. We also call these systems as a headless systems. So a headless system, how do they express their internal feelings, their emotions, their behavior? So we provide some small input output devices like LED or buzzer or some LCD, some motors, some sensors, some actuators, and so on. So in a minimum system, do not populate everything. Just connect one light emitting diode and then show the behavior of the program on the LED. Because we are talking about the minimum system, because first time we have developed that product with a new CPU, new design, new technology. So we need to understand first the architecture, the programming, the tools, and then executing the program in a given circumstances. All right, that is called a minimum system. How do you program it, that minimum system? Either you should have a programmer, some specialized equipment, because here it's not a computer where you have a hard disk, pen drives, internet, keyboard, display, CMOS setup. These things are not there. None of them are not there. Simple CPU. So you have to program it. So if you want to program it, you must have some provision to program it either through programmer or through some USB or through some specialized equipment called JTAG programmers. So those things we connected to some another computer and we write the programs on the another computers, right? And then from this computer, we transfer the code to the CPU. This is called minimum system. So whenever you develop any new product, a software and hardware, make sure start with always minimum. Later on, you can populate like Wi-Fi, Bluetooth, motors, sensors, actuators, touch screens, all those things you can slowly populate it. once the heart start functioning, the brain start functioning. All right, so that's the thing what is called a minimum system design. Since we are talking about Internet of Things today, so what is a Internet of Things? Whatever so far I said, there is a computational unit called controllers. There is a sensors because you require the data, right? And then you also require some communication, right? You need to transfer the data on the internet. So Internet of Things. Internet of Things means internet has to be there. Of things. What do you mean by things? Things means devices. Device is not a computer, undoubtedly. It is other than the computer. Things means it is a some hardware which is designed by you. So that things will consist of sensors and computational unit. So communication, computation and sensing is all about Internet of Things. If any of them is missing, let's say if internet connectivity is not there, sensors are not there, computation is not there, then you cannot call it as a Internet of Things. You may call it some embedded system, you may call it some cyber physical system, you may call it some automation and so on. But today, the new generation, the future is all about Internet of Things. Means undoubtedly there are sensors, there are high-end computational devices like microcontrollers, and that data has to be dumped, put on the internet because people wants to connect the devices globally. It's all about global communication. So your television is connected on internet. Today it's not about a popular TV channels. You want to connect your TV to the data centers. Means your TV acting as a client and there is a server data center and the communication is happening between the client and server. Your air conditioner is connected to the internet called as a smart air conditioner. Means through your mobile phone from anywhere in the world with the help of some app you can operate your television, your air conditioner, your LED bulb, your refrigerators, your washing machine, so many industrial applications. Like for example, your four-wheeler, two-wheelers, right? When you are crossing the toll booths, you are supposed to pay the tax, the toll. So that means your car is having a tag. The tag is connected to the some RFID reader in the toll booth and it is connected to the internet data center to the financial segment to your bank account to your account and it is deducting the money, then only the gate is open. So communication, computation, sensing is happening, including your electricity meters, water meters, everywhere. So many things are yet to be done. That's the beauty of the future generation. All the devices are globally connected. Earlier, we talked about human communication, websites, web servers, social media things. But today we are talking about machine to machine communication, M to M communication, device to device communication. If you look at the earlier generation, it's about human communication. When you say human communication, the population is limited. Let's say, for example, if a country is having 10 crore population, then how many communication devices are required? Worst case, let every person is having one mobile phone, so one connection is required. That's it. That is the upper limit you require for communication. But if you look at the device communication, if every TV is connected on internet and they are communicating through audio and video, look at the bandwidth requirement. Watching a movie through internet, every house, every mobile phone, and I also said about these electricity meters, water meters, toll booths, like that, agriculture applications, we will see all other applications. Such a high traffic is involved, and what is the population? Every day it is doubled, tripled because they are penetrating in so many fields. Every invention is creating a huge population on the internet domain. So how hope now you can understand the the scope in the machine to machine communication, the traffic in the machine to machine communication, and the bandwidth requirement. That is, today we are having 4G, very soon 5G. But even if you keep on improving your bandwidth requirement, still it is not enough. There is always a scope because the devices population is keep on increasing. So in Internet of Things, that's the beauty of it. It's not about human communication. It is about device communication. Like say for example, driverless cars, drones. Like that, if they are not at come, they are not even hardly less than a percent, fractional. If they also started coming, then imagine the amount of data computation has to happen from the workstations. Because every system, every car is an expert system, is as good as a supercomputer. Launching a missile, launching a satellite is much, much easier than driving a car in an autopilot system, because it has to acquire 360 degrees the entire traffic and then take a decision. So imagine the kind of parameters it has to consider, the kind of obstacles it has to come across, the kind of environmental conditions it is keep on, things are keep on changing, and then the complex mathematical models one has to build. That's the beauty of Internet of Things.